Hey everyone, here is an example problem using Kirchoff's rules. So we have another multi-loop circuit, and we need to find the current through the 8 ohm resistor, the EMF of the bottom battery, and there's this unknown resistor R up here that we need to find. Alright, so I'm going to start with finding the current through the 8 ohm resistor. So if I need to find current, I'm thinking that the junction rule might be useful here. So let me just name these junctions, okay? So we have like this common language here. We're talking about this. I'm going to name this junction B, and I'll name the one on the left here junction A, if that's cool. Alright, so need to find current here. I need to find this I. Alright. So if I look at junction B, I'm going to use the junction rule because I'm talking about current here. And I'm going to do this for junction B. So at junction B, let's find the current into it. Well, I can see that this 2 amp current is coming into junction B. And so I wonder what the current is on this branch above junction B. Let me kind of backtrack here. I have this 4 amp current here through this unknown resistor, and this battery in series with it. So the current coming down is 4 amps as well. So I know that the junction rule tells me that the current in equals the current out. And the current into junction B is 4 amps plus 2 amps. So the current out is 6 amps. So that means that this current going through the 8 ohm resistor is 6 amps. Alright, so next up we want to find the EMF of this battery. No one said anything about these batteries not being ideal, so I'm assuming that these batteries are ideal batteries, and that in this case the EMF is equal to the delta V across this battery. Okay, so we're going to be talking about delta V, so I know I'm probably going to be using the loop rule. So let me see if I can find a loop that contains this battery. I'm going to start up here, and I can go through the 8 ohm resistor, through this battery, up, and I'll keep it simple here. I'll just use this lower loop down here. So we're going to use the loop rule for this lower loop, or the bottom loop. And we can start anywhere, but I'll start at junction B here. Okay, I need to go across this 8 ohm resistor. It's going to be a loss of electric potential, delta V across the 8 ohm resistor. The next thing I need is to go through the battery. So that's going to be plus the EMF of the battery. And I come up this branch and through the 2 ohm resistor, so I'm going to need the delta V across that 2 ohm resistor. Alright, and then I'm back to the beginning. So this equals 0 volts. Let's see what we can get out of this. I don't know the delta V across the 8 ohm resistor, but at this point I do have the resistance and I have the current through it. So I could easily find the delta V across the 8 ohm resistor. I could actually model that as its current, which is 6 amps, times its resistance, which is 8 ohms. So I'll figure that out in a minute. Plus E, which is what I'm looking for. And I also don't know delta V across my 2 ohm resistor here, but I'm going to use Ohm's law here. I know that that delta V is equal to the current through it, which happens to be 2 amps, and the resistance, which is 2 ohms. And all of this is going to equal 0 volts. So I'm getting negative 48 volts plus E minus 4 volts equals 0 volts. So I know that E is equal to 52 volts. Alright, next up is I want to find the resistance of this unknown resistor. So right up here at the top. So the loop that I've already made is not going to get it done here. I definitely need to have a loop that contains that part of this multi-loop circuit. So I'll start here, come down. I'm going to go all the way around. So my loop went off the page here. Sorry about that. Come all the way around here. I'm going to go outside and come back. So let's apply the loop rule for the outside loop. And again, I just want to think about anything that will cause the electric potential to change. And again, you may start from anywhere in the circuit. I'll start here at junction B. I'm going to have a loss of electric potential across the 8 ohm resistor. I'm going to gain electric potential or move to a higher electric potential as a result of going through the battery. Now I'm going up this branch, not encountering anything until I get to our unknown resistor. So that's going to be a subtraction of delta V across the unknown resistor plus the delta V at this battery. And then we get back to where we began, so this all equals 0 volts. We've actually solved for a lot of things we need here already. We already know the delta V across the 8 ohm resistor that was found earlier to be negative 48 volts. The EMF of the battery is 52 volts. The delta V across the unknown resistor, okay, that one we don't know. But we do know the current through it, which is 4 amps. And we're going to multiply that by our unknown resistor. And we know the delta V across that top battery, it's 18 volts. So all of this should give us a sum of 0. Okay, when I sum up these three whole numbers, 52 minus 48 plus 18, I get 22 volts. So I've got 22 volts equals 4 amps times this unknown R. So I'm going to divide both sides by the 4 amps. And we come to find that R is equal to 5.5 ohms. Okay, so this is just a quick sample problem of using junction and loop rule to find unknowns that you need in combination with what you already know about Ohm's law. So let me know if you have any questions, and I'm happy to help.